I'm Ryan, and we are doing Lab 2. This here is a 10K resistor, and we could tell that because it has a brown, a black, and an orange stripe. And if we plug it in,
like we just said this is what we did.
And we get a resistance load of close to 10.
Oh.
What happened? Okay, so now we're gonna mount the same resistor in series with the other one. And the resistance is about 220, which is double what we had before.
We are now connecting a third identical 10K resistor in series with the rest of them. We get around 30K ohms of resistance, triple the resistance of one resistor.
This is the fourth resistor of the same resistance.
It's just gonna be in you the entire time.
And now we get about 40K ohms.
And this makes sense. It's 39.5.
Oh.
In this video.
Now we have to figure out that.
Basically, we've already done everything with the video.
Are we gonna have to do it in
My entire thing is just
And now we have the graph. It is just linearly increasing by a roughly 10 for every one increase in the amount of resistors. We can extrapolate that the resistance for n identical resistors in series will equal n times the resistance of each resistor. So 10 in this case.
So now if we plug two resistors in parallel, the resistance becomes half, which goes from about 10 to 5 kilo.
When we plug in the third resistor, it becomes a third of what one resistor is capable of, and we get a resistance of around 3 1/3. A fourth resistor in parallel makes the total resistance a quarter of what it would be for one resistor.
Let's try not to react them.
I know the two middle ones are 9.5. The first one.
We will then plot these values and get a graph. See, the graph follows the semi-parabolic decrease. From this data, we can extrapolate that the amount of resistance will be 10 over the quantity of resistors used, with 10 being the specific resistance of each individual resistor.
Now measuring voltage drops across our circuit. The voltage drop across the resistor is 2.74. Across our LED is about 2.47.
So when we are measuring the current, we find out that the current in the circuit is 0.13 milliamps and is actually the current
Yeah, the current. So the current split into two because it's in parallel.
oh yeah that
That makes sense.
I don't want to unfold
no matter where in the circuit the
That's so weird though.
the multimeter is placed. It measures in series with the rest of the circuit, unlike the voltmeter, which measures in parallel.